Now let's start with our new lesson, lesson 4, potential energy. Let's explain the potential energy today. Now the potential energy, as we said yesterday, it is the energy stored in an object. So energy, it is mean, potential, it's mean like energy is stored. Simply, it means that the energy has the ability to do something useful later on. So like when you bring something, save it in your body, then you use it later on. This is the meaning of potential. It is energy that is stored, and later on, when you decide to move, you will use it. Now let's see some examples of the potential energy. Like the first one here, a stretched rubber band. When it is, since now it is in your hand, it has an energy, but you will not see it. But when you try now to stretch the rubber, it start to moving, so it's here potential start to use, so that's why it will that's mean that has energy. Another example, water at the top of waterfall. Yo-yo held in your hand. I like the drawn bow and arrow. These are an examples of potential energy. It's stored an energy. It start to use it when it start moving. Now, the higher an object is, the more potential energy. So the first factor that the potential energy depend on is the higher, or the distance, or the height, you can say. And the second factor is the mass, where the more mass on the object is, the more potential energy has. So the potential energy depend on the height and the mass. Higher mass or higher object, more potential energy. Greater mass or more mass, you have a more potential energy. Look at these two examples of this one here. Which one has the more potential energy? A or B?
It's A.
It's A. Why?
A. Because it has more mass.
Yes, exactly. Because it has more mass, so it has more potential energy. Now here, imagine now, I will say that's how, when if you change the heights of the object's heights, how can you change the potential energy? Now imagine that you drop an apple from the top of one of these three things. Where will be the most potential energy? At A or B or C?
Is it A?
Why?
Because it has more mass than B and C.
No, here you drop, no, you talk about an apple that you drop it from A or B or
Is
C.
it B?
Which one has the greatest potential energy?
Is it B?
Why B, Haneen?
Because it's dropped from the space that it's dropped from is not so much, so after it's going to be dropped, it will have the potential energy.
Okay, but which? Well, both on the three cases you have a potential energy, because you drop an apple from here, from A and from B and from C. You drop an apple. In the three cases, we have a potential energy. But which one is the most?
It's A because it's the longest, the tallest.
Yes, bravo.
It
is A because it has the longest height. So the higher object
Teacher,
will
what
be
was? There was a rule for potential energy. What was it?
MGH.
It's related to...
Wait.
MGH.
Yeah. Just step by step. So here, the potential energy depends on the mass and the height. As you see here, more mass, more potential energy. more height, which is for A. So A, it has the most potential energy. A is greater than C, greater than B. Because the height here for this one is greater than the higher for the crane, greater than the highest for the chair.
Teacher, so the more distance, the more potential energy.
Yes, exactly. Now here we have two examples for the potential energy. One of them we said yesterday, like the massive pull of the demolition machine. That's it store energy when it start going to demolate or to demolate the building to going up and down. It start to use her potential energy. It store the potential energy, and then the stretched bow also. When it has a potential energy, when you move it backwards, it start to use her potential. Then when you press on it or you move it, it will go forward. So now the two examples above, in the previous slides, illustrate the two forms of potential energy that to be discussed in this course. So here, after we talk about the potential energy, let's talk about now the two types of potential energy, gravitational and elastic. We have gravitational potential energy and elastic potential energy. Let's start now with the gravitational potential energy. Gravitational potential energy is the energy stored in an object as the result of its vertical position or height. It is an energy stored as the result of its height. The energy is stored as the result of the gravitational attraction of the Earth for the object. So we say that the potential energy depends on the height. Here, the gravitational potential energy, it's stored it's because a result of its vertical position. Okay, why? Because there's a gravitational attraction that, like in the ball here, the ball here will going down from up of the tower down because of there's a gravitational attraction down. This gravitational attraction pull the apple down. So since it is pull the apple down, it has more height. The results of this vertical height or of this gravitational attraction, you name it gravitational potential energy. Now let's see what is the formula for the gravitational potential energy. There's a direct relation between gravitational potential energy and the mass of an object. More mass, that means has a greater gravitational potential energy. And like what we said before, and height, more of the higher object that has the more gravitational potential energy. The mass and the height. So that they said the potential gravitational energy, or PE. PE, it's mean potential energy. PE. So PE, the potential energy, the gravitational potential energy is mass times G, where's G is here 9.8 or 10 Newton kilogram, or the gravitational strength, or G, you know it, and the height. So here the potential energy is mgh. M, mass, G, the gravitational force, and h is the height. It depends on the height, not the distance. Be careful, I'm talking now on the vertical distance. Height here, it's mean vertical distance. Since I'm talking about the gravitational, so you know that the impact of the gravity is vertical. So I'm take care, or I'm concerned here on a height of the object where it's full. Now, to determine the gravitational potential energy of an object, you must have a reference, like how we said in our first chapter. Everything, when you want to find velocity, distance, you want to measure everything in math, you need a reference point. Here also, if you want to find the potential energy, you need a reference point. Where is the reference point? You imagine it as here on the ground, as an example. So now, this is our reference point. We say that our reference point, or the ground here, is the position of zero height. So if you want to find the potential energy for the man who is in the first position here, you have to use this height. And as an example, this is 2, this is 4, and this is no, not 2. This is 4, this is 2, and this is 4. 4, 2, and 4. So at the first case, you have to say that PE at the first one is his mass, as an example, 60 kilogram times 10, which is G, times the height, which is 4. Now, what is the unit for the energy?
Joule.
Joule, bravo. So it's 240 joule. And potential energy, and the position 2 here is his mass times G, which is 10, times the height, which is 2. So if they give me this distance between the first position and the second position as a 3, as an example, it doesn't matter. I don't want it. I want only the vertical distance, or the height, from our reference point up to where is the man now. So times 2. And the potential energy, and at point 3 here, we have to say it is his mass times 10 times 4, which is 240 joule. So since you need to find the potential energy, you need a reference point. This reference point, it has a 0 height from the ground. Then after that, you have to find the potential energy with a vertical height. Let's have more examples. Look at this one here. I want now to determine the potential energy for each case, A, B, C, D, E, and F, knowing that the potential energy at the highest, at the top here of the platform is 50, and at the lowest point here is 0. Now imagine now here the distance is 1 meter, 2, 3, and 4, and 5. Now, let's find the potential energy at point D, sorry. At point D, we have to now imagine that also from here, yeah, okay. Let's find the mass of the ball. The potential energy at the highest point is 50 joule. It is mgh. The mass is unknown. G is 10, and the height is 5. So what is the mass of the ball? It's 1 kilogram. So now I know the mass of the ball, which is 1 kilogram. Now let's find the potential energy at point D. mgh. Now what is the mass of the ball? It is 1. What is G? It is 10. And what is the height for the ball at point D?
1.
It is 1. Bravo. So the potential energy at D is 10 joule.
Teacher, from where you bring the 10?
It is G. 9.8 or 10.
Oh, okay.
We said that the weight is m times g. Did you remember this?
Yes, yes.
So this is a g. It's a
Okay.
gravitational constant field. Now, I want to find now the potential energy at point C. We said it is mgh. The mass is 1. The g is 10. And the height, what is the height at point C here? The vertical height to reach point C.
2.
2.
It is 2. Bravo. So it's a 20 joule. Now, the potential energy at point B. It is 1, the mass, times g, 10, times the height. What is the height at point B?
3.
It's a 3 from here. So we say it's a 30 joule. Now, the potential energy at point A now.
It should be 40.
Yes, it will be 40. Let's rewrite it here. Is m, which is 1, times g, which is 10, times the height, which is 4, which is 40 joule. Now at point E, here, try to change the color here. What is the potential energy? Oh, sorry, this is E. What is the potential energy at E? The mass is 1. The G is 10. Now what is the vertical height?
0.
0. Thank you. So
Yeah.
it will be 0 joule. And at F,
It should also be 0.
it's also 0 because the vertical height here is 0. It is on the ground. This is how to find the potential energy. We must look at the vertical height. Is it clear?
Yes.
Yeah.
Yes, we can.
Now here we have the solution, but in another way. Like if you have like the mass is elevated to the 4/5 to the height, so you have to multiply 4/5 by 50, you will get 40 joule. Or you can solve it as I did. Now let's talk about the second type of the potential energy, which is the elastic potential energy. But before I'm talking about it here, the elastic potential energy, has a formula, which is 0.5 times the K, which is a constant, spring constant, times X, or mx, or no, something like that, m times X. Okay, but you didn't take it. Yeah, it's not written in your book, so we don't care about it. We not only talk about the gravitational potential energy. The elastic, it has a formula, but we will not talk about it. I will not take it this in this book here. So the elastic potential energy, it is the second form of the potential energy. The elastic potential energy is an energy stored in elastic material. It is an energy stored in an elastic material. The previous one, we talk about it. It is related to the vertical height because of the gravitational height. Here, it is stored in an elastic material. When you stretch or compress something, like when you talk about the rubber band. Since you start to stretch or compress something, the elastic potential energy here, it starts working. So the elastic potential energy can be stored in rubber band, bungee cords, trampolines, spring, an arrow that is drawn into a bow, etc. You know the trampoline, where the kids are jumping. We know the spring. This is the spring here. It has an energy. Since you press on it, when you remove your hand, it will come back. So because it has an elastic energy, it stores an energy that is stored when it starts stretching or compressing, they will use this energy. Therefore, this spring here, the potential, the elastic potential energy here is K times X, and they multiply it by 0.5 K times X. I think like this, inshallah, but it's not with you. This is the potential or the elastic potential energy, how to find it. But as I told you, it's not important for you. So here, these are the, let's take care of the, focus, sorry, on the definition of the elastic potential energy, where it is the energy that is stored in an elastic material, such as rubber band, trampoline, spring, the arrow, and the bow, and so on. And here, the factor that's depend on it is more stretch, that's mean more stored energy. Imagine here you have a spring. When you stretch the first spring, you imagine here you have a ball. And then you remove your hand, the ball will going up to this distance. But when you stretch this one to going down, to make it very, you press on it more than the previous one, the ball will fly up as a greater distance. Why? Because the more stretch, that's mean the more stored energy. This more stored energy, that's make a greater force with a greater distance on the ball. That's the work done, that is applied on the ball will be greater than the first case. So the elastic potential energy is an energy, that is stored in an elastic material, such as rubber bands, spring, trampoline, arrow, bungee cords, and so on. And also, it depends on the stretch and the amount of stretch. More stretch, that's mean more stored energy. Is it clear?
Yes.
Yes.
Now, let's come back to the gravitational potential energy. Here now, a cart is loaded with a brick as pulled at pulled at a constant speed along an inclined plane to the height of seat top. If the mass of the loaded cart is 3 kilograms and the height of the seat top, the height here is 0.45. Okay, for this one here, I need now to find the potential energy. Now, the potential energy is mgh. Now, where is m? They told me it's 3. G is 10. And the height, what is the height now here when it's reached the highest position? The vertical distance, it is 0.45. So 30 times 0.45 is 13.5 joule. So the potential energy here at the height of the seat top is 13.5 joule. How will we find it? By using the formula mgh. M is the mass, which is 3 kilogram, G is 10, and H, where is the height? That's given the vertical height, which is 0.45. Now, if a force of 14.7 Newton is used to drag the loaded cart along the incline of distance of 9. So here the inclined distance is 9, and the force that's needed to pull the car is 14.7. How much work is done on the loaded cart? I need to find the work. Now, what is the formula of the work here?
Force multiplied
The
by
work
distance.
is
Force times distance,
by
yes.
distance.
What is the force here?
It is
14.7.
14.7.
And the distance?
0.0.
2.9.
It is 9. 0.9, sorry. So 14.7 times 0.9 is 13.23. So here, to find the potential energy, as we see, we look at the vertical height. But when you find the work, you must look at the distance with the direction of the force. The height here is not the direction with the force, so I will not use it. I will search about a distance that is with the direction. That is with the direction of the force. If this is F, this will be the distance. So that's why we found F times D as 13.23 joule for the work. Is it clear?
Yes, teacher.
Yeah.
Yes, teacher, thank you.
Yeah.
Now let's see these examples here.
Teacher?
Yes. Yes.
Teacher, the unit of the power is
The power is watt, but work and energy is joule.
what?
For the power is watt. For the energy and work, joule. Now let's find the potential energy at point A. Imagine now here that the mass is 10 kilogram. Let's find now the potential energy at A. We have to say mg times h. Now where is m? It is 10. And g, it is 10. And what is the vertical height here? From the ground, from the reference point, up to the top of the hill. It is 2. Is it right?
Yeah.
So
Yeah.
it is 200. This is for point A. Now let's find the potential energy at point B. mgh. Now, where's the mass? We said it is 10. And the g, it is 10. Now, what is the height? It is 4 or 2?
It's 2 because it's the vertical height.
So, is it 4 or 2?
No, it's 2.
It is 2. So here, not any given distance would be used. If I told you now, like the force that I needed to pull the stone or the rock up to the hill with a distance of 4, you will tell me that the force you will use this for. But since I want to find the potential energy, I need the vertical height. Where is it? 2. So here it's 200 joule. Now look at the last one here. Imagine now that this is 1, this is 2, this is 3, this is 4, and or no, not like this. 2. Now this is 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay. Now I want to find the potential energy at point C. I have to say mg times h, whereas m is 10, g is 10, and I need to find the height now. هلا, shall I say 1 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the distance where the ball is going up, or the vertical distance?
The vertical
Vertical
distance.
distance.
Which is 2. Yes, bravo. You have to use also the vertical distance, which is 200 joule. Is it clear?
Yes.
Yes.
Now, let's have this example here. You lift a 100 Newton boulder 1 meter. So here you have a 100 Newton. It is the weight. So here, in other words, but before I start, potential energy is m times g times h, and m times g is the weight. So when you multiply the weight times the height, you will get the potential energy. So here, they give you the weight. If they give you the height. Now, how much work is done on the boulder?
It's
I need-
100 times 1.
I need the work. Wait, honey. I need now the work here. Okay? So to find the work, what do I have to say? It is the force times the
But
distance.
so it's also 100 joules.
So what is the force here? It is 100, as Hanin said.
In newtons
And
multiplied by meter.
The distance is 1 meter.
what is the distance here? It is 1.
1 meter.
So the final answer as 100 joule, as Susan said. Look at me. So the work here is F times D. The force that is used here, there's no force, just only the weight. So it is 100 times the distance, which is 1. So it will be 100 joule. Now let's find, this is for A. For B now, what is power is expended if you lift the boulder in a time of 2 seconds? How can we find the power?
It's the work over time.
Time.
Work over time.
Yeah.
Bravo. What is the work we found it before?
100.
100
and
joule.
then divided
And
by
the time?
2 seconds.
It is 2. So 100 over 2, which is 50 watt. Now let's solve C. What is the gravitational potential energy? Now we imagine that this is our reference point. So I mean that he's lifted the work with 1 meter. So the potential energy here is m times g times h. So as I told you, we can say it is the w times the height. So it is 100 times 1, which is 100 joule. Or if you don't want to use it as WH, you can say that the weight is 100 Newton and the weight is m times g. So from here we have to say that m is 10. Then we are going back to say that is 10 times 1, which is 100 joule. Is it clear?
Yes.
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 Now, at the end here, potential energy converted to a kinetic energy. When the stored energy begins to move, they start to use their potential energy. They transfer this potential into kinetic energy. And this is the kinetic that, inshallah, we will explain it next lesson. But here, just an introduction that the potential energy, that is when it is stored, when it start moving, they use it. How they use it? They convert it to a kinetic to use it when they are running, as an example here. Do you have any question?
No.
No.
Okay, thank you so much.
Thank you, teacher.
Have a nice day.
Have a nice day.